Why GPS shouldn't work, but does. GPS is magic.
Magic?
You click directions, and somehow, a bunch of metal boxes flying 20,000 kilometers above your head know you're standing outside a Taco Bell. That shouldn't work. At all. GPS is not your phone. It's not Google Maps. It's a constellation. And here's the dumb part. They don't send maps. They don't send directions. They don't even know where you are. All they do is broadcast two things: the exact time, down to billionths of a second, their own position in orbit. Each satellite is basically an atomic clock yelling, "I'm here." The time is 10 hours, 0 minutes, 0 seconds, 0 milliseconds. Your phone? It listens to 4 or more satellites and says, "Okay, if that signal took this long to reach me, you must be this far away." Do that with a few satellites, boom, that's my location. That's trilateration, not triangulation. Stop calling it triangulation. Here's the problem. Light is fast. Like
15 miles over the speed of light.
too fast. 1 nanosecond of error, you're off by 30 centimeters. A millionth of a second, you're in the wrong city. Now imagine trying to keep perfect time when your clocks are moving at 14,000 kilometers per hour in orbit. Because of relativity, those satellite clocks actually tick faster than clocks on Earth, about 38 microseconds faster, which sounds tiny, until you realize that means your GPS would drift by 10 kilometers every single day. Yeah, Einstein broke GPS before it was even invented. So how do we fix it? First, atomic clocks. Each satellite carries multiple atomic clocks that are so precise they lose about 1 second every 30 million years. Your phone's quartz clock loses seconds every day. Truly the same league. Second, relativity patches. Engineers literally pre-adjust satellite clocks before launch, so they tick at the wrong rate in space, which, thanks to relativity, ends up being the right rate from Earth. Third, constant correction. Ground stations around the world babysit the satellites, uploading updates so they don't drift too far. Think of it like a giant cosmic group chat, just to make sure your Uber finds the right corner. And even after all that, GPS still sucks sometimes. Signals can't get through water, metal, or even dense trees. The ionosphere bends radio waves, throwing off timing. Your phone sometimes listens to the wrong signals, so your short walk suddenly looks like parkour across rooftops. Oh, and GPS is weak. The signal power from a satellite is about the same as a light bulb. On the moon. That's what your phone is trying to hear. Meanwhile, you can't even hear your mom yelling "dinner's ready" from the next room. So, why does GPS work? Because engineers brute force the universe. 4 satellites minimum, 3D location. More satellites equals more accuracy. Assisted GPS uses cell towers and Wi-Fi to help. And Einstein's math keeps the whole thing from collapsing. The result? A system so precise it guides planes, ships, missiles, tractors, delivery apps, and yes, your Taco Bell run. So, yeah, GPS shouldn't work. It relies on broken time, weak signals, and math most people cheat on. But it does, because engineers are stubborn, which, in the end, is probably why you made it to Taco Bell.